Welcome everyone to this hybrid event arranged by the IET's Angling Coastal Local Network, which represents members in North Essex, Norfolk and Suffolk. Welcome to those of you in the local audience here at the atrium at the University of Suffolk, and welcome also to folks joining via Teams from other parts of the UK and indeed globally. Welcome. I'm Kevin Foster and I chair the Angling Coastal Local Network. I'll be your host for this evening. I'm delighted to introduce our speaker, Dave Millen. Dave is a long-time telecom innovator whose work spans digital switching, network management, and global standards. Founding force behind what became the TM Forum, he now serves as its chief architect, leading industry efforts in AI-driven operations and autonomous network architectures.
Welcome everybody, and thank you all for taking the time to come on quite a dark January wet night. Very much appreciated, and for those of you online, I hope you can hear me okay. So this is a sort of a summary of a personal journey from early stages of operations in telecoms networks to where we are now, where we're on the cusp of using AI and innovative technologies such as autonomous networks. So I'll give you a kind of a view over about how the industry has developed over about 30 years. So I called it Journey from Advice Notes to Intelligent Agents, and these are really at the opposite end of a spectrum, really. Advice notes are really low-tech pieces of paper, and intelligent agents are right at the leading edge of experiments that are taking place in the industry at the moment. Although, as many of you I can see in the audience were with me at various times in BT, some of you will know that BT did quite a lot of research on this in about the year 2000, and some of these concepts are just starting to emerge as practical things with practical benefits in the industry at large. So I structured this into really three sections. One is the first era, which is of manual people-centric operations. So it's all about operations rather than necessarily technology. And the second stage was a software automation centric era, where we started to see the rapid introduction of computer-based solutions to perform management of networks. And finally, we're on the cusp of moving to an era which is AI enabled and autonomous network operations based. That's where you have agents making decisions about what to do that are supervised by humans rather than humans actually making the decisions. Now, this has taken something like 40 years probably to go through, perhaps a bit more than that. And the early stage was the enabler for the first stage transition from manual to software automation centric, was really the widespread availability of economical compute and storage. And over a period of time, as you'll know, Moore's law, the costs of these items have been plummeting over this period. So more and more automation becomes practically justifiable through a return on investment. Behind this, there's been a move towards digitalisation, and this has been both in the networks and also in the operation support systems. And this is actually quite significant because this has been one of the precursors, one of the enablers for moving towards better automation and autonomy. And we'll explain some of these concepts a little bit later. And the talk really goes through a little bit about characterizing each of these eras and some of the things that have caused the transitions to take place. What are the enablers? So there are a couple of hidden issues to this. So it all looks like technology, this, but actually there are some drivers that are long-standing through all of these transitions. And these are around business cases, funding and risk. And to characterize the telecoms industry, it's always been a high capex industry. And it's when it got into software, this was an unfamiliar technology with uncertain returns. So the industry has been prepared to invest, but it wants evidence that it's going to see a return on that investment, which hasn't always been a smooth pathway. We're at that point with AI at the moment. We're at the experimentation stage, which is show me this stuff delivers real business benefits. And the business focus over all of these three eras has always been about improving the customer experience and using automation to reduce CapEx and also OpEx costs. And the other characteristic to the telecoms industry is risk aversion. So taking big gambles hasn't really been something that's been characterizing the telecoms industry. And this leads towards incremental improvements, minimum viable products, and inevitably technical debt in the solutions that are deployed. So these are some of the hidden things, which, to be honest, I don't think have changed much over 40 years. I think it's the way it was in the 1960s. There is a law, which some of you may have come across, called Conway's Law, and it says organisations design systems that mirror their own communication structures. And actually, this talk, if you listen to each of the steps, demonstrates this law is true. So it's about all of these things are enabled by the appetite of the organisation and the structure of the organisation at a particular point in time. Now, to the more interesting stuff, there are some technology enablers in all of this. And networks have transitioned from electromechanical analog networks to digital electronics and semiconductors. But the administrative automation has moved from paper records to digital records based on tapes and discs and those sorts of things. And the administrative processes have moved towards software program automation, sometimes called robotic process automation. And the other thing that's happening at this particular point in time is the increasing interest in autonomy, where decision making is not made primarily by humans in the operations centres, but a lot of the operational tactical decisions are being made by AI algorithms. And this is a transition of humans in the loop of the processes and the decision making to being humans on the loop. And it's the distinction between supervising somebody in a shop, telling them to do this, this, and this, so it's prescriptive, to delegating responsibility to somebody to run a chain of shops with some overall goals and objectives, i.e. some intent or goal. And we'll speak to that later in the autonomy section. And it also has allowed telecoms providers to think about moving from reactive processes to proactive processes. And historically, it's always been find a fault, get a fault, deal with it, go and fix it. What we're seeing in these autonomous decisions is the ability to predict faults, take some remediation action, which has some quite significant ROI benefits, as it turns out. So what did networks look like in the 1960s? And it's a bit of a horror when I sort of was searching with George for slides, to sit and think, yeah, I remember going around exchanges with step-by-step equipment. And I do remember analog frequency division multiplex transmission. And I also remember all the stuff about access networks. That's kind of the network switching perspective. And it's a bit of a surprise when you look at it, because you sit and think, this is so out of date. It's like, wow, a lot has happened. And indeed, a lot has happened. And if you look at the maintenance and the administration, we used to have things called, I think they were variously called engineering instructions and technical instructions. So there was a whole industry of replicating and producing instructions, which would then be read by humans and then carried out by humans. And if there was any form of automation, it was on the right-hand side of this, where we had meters that were counting units of usage. And the only automation that we were seeing at this particular point in time was basically taking photographs of the meeting and somebody then keying in the information. So this is where we came from. And a lot of the maintenance and operation stuff was based on the fact that a lot of the network and switching equipment really, it hadn't got any software in it. So you can't really use modern thinking about automation and software-based approaches. So it's not that our predecessors, when they were doing these things, were somehow stupid. They were operating within the engineering and the technology of the time that they were working in. So what we would see here is that networks were focused on telecom functions and technologies. So we had departments when I was in BT working purely on network technologies. The manual operations were focused on generally repair and order provisioning, driven by technical instructions. And manual functions were largely supported by very limited IT support, largely record keeping. There was a concept of advice notes, which I'll talk about, which is quite amusing, I think, when you think how we started off this. But we also had a system in BT called mechanised order handling, which was manual computer input. And it was printing advice notes for us. So the view of automation was extremely limited. It was in the context of the organisation at the time. And this is an example of Conway's law in action. And largely, it was just basically making simpler some of the manual processes, the paper processes, the provisioning procedures and everything. Probably billing was the first further advanced in terms of photographing meters, manual data input, and the billing systems. Those were really where the IT was predominantly. It was a commercial based activity. So for those of you can think back this far, advice notes were basically for taking orders. And I couldn't find a photo of this, but there used to be a plate, an aluminium plate with a couple of pins on it that you put a multi-part carbon copied paper on, and you got a stylus out and you wrote down on this piece of paper everything that needs to be done, and different parts of the paper went different places. So this is sort of illustrated here. So you write it all in one place, and the goal is to take the order and then pass one of or more of these copies to a planning department, who would then pass some information to a billing department. They would then pass on information to internal works, who would then complete the work. They would then also start external works, who would also involve in testing the service. And finally, there would be some premises installation. And the success was when all these bits of paper got back together, the job had been done. So the whole process was about using paper to drive a whole set of manual processes. And the early automation on this was largely, let's keep the processes, let's keep the paper, but we'll use the computers to do some of the work, which is obviously a very limited view of what was actually possible. So what happened in the 70s and the 80s was basically there was a very strong move towards digital software control switching, System X and later System Y. What we also saw is the rise of the internet and digital transmission systems. And we also started to see the introduction of digital fibre transmission in the core network, although the access network was still copper at that time. What that enabled us to do was all of those that come out of computer science courses at various universities now thought, oh, now we can get these like computers and we can connect them to all these networks, and then we can start to automate some of the things where we had to send people to go and do things on the network. So for example, I think it was TXE2, you had to run a wire through a frame in order to provision a telephone number on the system. Somebody had to go and do that. This basically System X eliminated all of this. But what did actually happen at this time, which is again another example of Conway's law, is there was a bunch of systems being developed from an operations and maintenance point of view, largely driven out of IT working into the network department. But equally, there was a parallel activity working on mainframes, doing front office functions, doing all the commercial based stuff like orders, billing, and all that sort of stuff. So what you're starting to see is the change in the network enabled a move in the maintenance approach, but also it showed an organisational split, which I'll tell you is still present in telecoms organisations, that the division of thinking between networks and the IT department is still there some 20 odd years later, and it's in the organisation, it's in the walls. So at this particular point in time, we're starting to do automation. There was an activity around end-to-end processes, and in particular the TM Forum was quite active in this area and defined a process framework which was been called various things at various points in time. Currently it's called a business process framework. The most popular name is an enhanced telecoms operations model. And what it actually said is all the processes you're doing in an organization can be put into a matrix, and the matrix covers end-to-end processes in the vertical direction, and it covers particular business activities in the horizontal dimension. And what you can do is you can take this library of business processes and string it together to create end-to-end services. And what's happening or has happened is the original focus was on automation, which covers the right-hand side of this diagram. But what we're starting to see with AI is some of the processes which were always assumed to be done by humans are now coming within the remit of automated systems or autonomous systems. So this particular piece of work was based on thinking coming out of something called Telecoms Management Network. And there were terms like BSS, Business Support Systems, Operations Support Systems, Enterprise Resource Planning Systems, and network management systems and element management systems. Now, I'll tell you, these words are used a lot in the industry, but the ITU's moved on and it no longer uses these terms, as it turns out. And indeed, in the TIM Forum, we're moving more towards a different model for describing systems and their functionality. But nevertheless, in all of these cases, these systems are performing some of these processes that have been defined within this map. It's been quite a successful activity because it's been around for something like 20 odd years, and it's referenced in all sorts of locations, things like procurement documents, like scoping out system requirements in procurements and things like that. So it's still quite alive and well. Now, the era of software automation centric approaches was really moving from automating a particular department's functions to moving towards an end-to-end process. So this was one of the things that was enabled by IT systems, was to start to think about automation for end-to-end processes, largely focused on customer experience or on operational efficiency. And what we saw is a big swing towards defining end-to-end processes, particularly around order to cash, trouble to resolve, billing, planning and design. And the operational focus was on processes and then realized by systems, whereas the earlier phase was about departments, existing departments, and how to actually automate the functions of individual departments. This was also accompanied by lots of organizational redesign to follow processes and things like that, which I'm sure many of the people in the audience have been involved in those kind of projects. The core concepts were captured in the ITU Telecoms Management Network standards, which actually have moved on quite a bit since this time. And also the systems were focused on automating processes. And the result of that is that the interfaces between systems are based on tasks that need to be performed by one process on behalf of another process. So the APIs follow a task-centric model. They pass an activity that needs to be done together with the parameters that describe what that task is supposed to do. Now, the challenges are with all of these, with this automation, is that actually the API technology evolved every 3 to 5 years. So whatever API you produced, by the time you've defined it, you're sort of like 2.5 years into it. And by the time you've gained consensus for adoption, you're around about 3.5 years. So you've now got about another year before somebody comes up and say there's another technology that we should have been using. And this has been a major issue in the telecoms industry, is that the IT life cycles are much shorter than the telecom life cycles. And I can tell you there are APIs that I saw in, say, 1988, 1990, which functionally haven't moved at all, but they're completely transformed in terms of the technology that was being used. At that time, it was OSI management. Now it's all around web services and REST-based API systems. And it also, there's been a disconnect between IT and network APIs and their technologies. That's another factor that, because of the organizational distinction between the network departments and the IT departments, the favored technology for APIs and integration varies according to departments. And that's another example of Conway's law driving the actual technical behavior of organizations. So what happened after mechanized order handling, which I don't think lasted very long, actually, it's just a little bit before my time, is that decided to build a customer support system where instead of the thing being automating the production of the existing paperwork to go around the organization, now it provides interfaces from each of the departments, and the paperwork basically flows as internal data stored rich information within a single system. And this sort of shows like ordering reporting and billing inquiries. And essentially the system captures the end-to-end process within a single system. And the people now are working into the system. There's no paper in all of this. So that was one of the transitions that started happening with BSS, with what was the BT Customer Support System, CSS. Actually, even today, this has proven to be quite a successful system, because some of the engineering behind this, particularly around the data modeling, particularly around some of the realization, really was really, it's really top drawer stuff. It was really excellent. And some of the early work that was done in here, you'll still see some of those concepts and principles still around, particularly in data models and information models. Well, what happened at that point was that it became apparent that building a large IT system is really prone to cost and time overruns, because you effectively got a very large set of teams of people working together, and they've got to be coordinated, and there's conflicting priorities and demands. So you spend most of your time trying to resolve the conflicts rather than doing the work. And so the feeling was it needed to be broken up. And concurrently with this, there was also an emergence of basically best of breed products. There were lots of IT companies producing products for like inventory management, things like ordering, orchestration, repair type process. And the challenge for an organization, this would be BT and most of the large organizations, was, do we really want to develop all this stuff ourselves, or do we want to buy best of breed and we can then customize the best of breed? Okay, so that's the kind of thinking process. Now, when you get down to the risk aversion and you get down to ROI, it's very easy to see how anybody can produce a business case that makes it absolutely clear that you should be buying best of breed products, even if you spend as much on the customization as you did buying the product. Nevertheless, this argument, when you get down to the finance, the organization, this is the argument that captures everything. Now, one of the problems with this is that now, whereas all of these interfunctional process interfaces were inside a single system, so they're just like API calls. Now we need to have APIs between these systems, and there's a large number of systems that we need to connect. So now what we've swapped is the cost of a large development by buying best of breed products, customization, and managing and defining lots of interfaces between the products. And that has that's certainly been a challenge. So what happened was we moved from monolithic systems to distributed systems. This is also aided by the move towards mini computer type solutions rather than mainframe, which were clearly cheaper than mainframes. You know, if you look at it from a cost performance point of view. You move from large software development teams to distributed parallel agile development, and the processes, instead of being just internal system logic, now need to be basically distributed logic linked by intersystem APIs. And you also subtly move from centralized databases towards distributed databases. Not all of this is good news, but it is what drives the business case, regrettably. So this move towards sort of distributed systems, best of breed products, led us to the idea of an OSS BSS architecture, because whereas that used to be like the internal software development inside a single, say, IBM system or set of applications, now we're trying to integrate lots of things from different places. So now the argument is we need an architecture, and we need the suppliers in the industry to building against that, so that the numbers of interfaces that we've got, that we don't have to carry the cost of developing all of those interfaces ourselves. That's the theory. It's not as easy as you might imagine. Now, there's a bit of a synthetic diagram, but what was happening over this time frame, see the screen a little bit better, we were seeing a few things happening. One is that the number of systems was going up. So in this distributed environment, every new business requirement was, we need to build another system. And every system that you put in brings in a number of interfaces, and it's not linear. It's more like a square law. And then the other thing that you got is that the system costs are going up. So you can see the sort of system costs going up. Now, there was a point in time, which I'll come on to in the next few slides, where it was quite obvious that this trajectory of increasing numbers of systems, increasing system costs is completely unsustainable, because all it's doing is the overheads of the IT are going up all the time, and there has to be some limit to this. And the question is, so what's the value of these systems? Rather than it being judged on a project by project basis, what is the business value for all this? And you can see some of the things that were driving this. Now, what we are seeing at the moment is that there is a real recognition that there needs to be some kind of simplification of systems. This is kind of last year's story, I would say, or last 5 years' story. But you'll see synthetically on the synthetic diagram that these things are coming down. It's also interesting that when you start to look at AI, instead of building a system that does one function statically, it is actually possible to build a system that you set goals and objectives for in multiple areas of your process estate. And so you can end up with fewer systems and fewer APIs by moving towards AI. But on the other side of the trade is the Faustian bargain that you need to be able to trust that the AI is doing what it's supposed to do, and that you actually can observe and monitor it, which is not a proven situation at the moment. So this is starting to come down, and this is synthetic, just to give some indication of, we had the rise of lots of systems and interfaces. Now we're seeing some consolidation in the industry. Now, around about, I think this was 2006, George Glass gave a presentation at the TIM Forum, and I have a couple of his slides here, which are public domain, by the way. And these were really about a plea for the industry getting its act together, because it was recognised that running internal development teams was no longer sustainable. And this was exactly the slide. Over 3,000 systems. Actually, that was being a little bit economical with the truth. 4,000 would have been a more accurate number. And it was increasing yearly. And it's vertically integrated, so they're built for particular things. It's highly complex data because now it's distributed, and a lot of the data is moving through APIs rather than being in a centralized database. Lengthy and costly development cycles. This was actually the main issue here, is that from a business point of view, the time it took to get a business capability into operation was just taking too long. And there were excessive maintenance and support costs, and there were also reliability and stability issues. So, for example, when I think broadband was being launched, there had to be a freeze on all changes on a given system to only accommodate changes needed for that one program. So what you were finding was that all the other programs were getting stopped, and it's all to do with this highly complex interconnectivity. Also, the support costs, I think there are a couple of people in the room who actually looked at some of these numbers. When people added up what the cost of these allegedly 3,000 systems were, I think the word shock would probably be a good way of describing it. We can't possibly be spending that amount of money. And the answer is we were. And were we getting value for money? Probably not. Could we sustain the growth in the money? And at this time, all the budgets were based on systems. So what was proposed is to have a sort of a systematic functional architecture that group functions into particular areas. And this just happened to be the one that BT put together that George was advancing in the industry. This was at the time called, I think, the matrix architecture, matrix platform architecture. And it was basically putting all the ETOM processes into a smaller number of groupings that you could then associate budgets and business value to for each of these areas. And also, and I'll show on the next slide, was that they were interconnected by APIs, and you could reduce the number of APIs that you need, standardize them. That was the thinking process at this particular point in time. And there were other examples similar to this from AT&T, MCI, and a number of others. There were the storyline at this particular point in time is all around, we need to move to platforms, we need fewer platforms, we need to have fewer APIs, the APIs need to be industry standardized. And the target was 14 platforms and 100 systems, Well, didn't quite make 100 systems, I can tell you that, but it certainly wasn't growing at 3,000 and going north. So this was a slide that George was promoting, which was departmental systems were growing on the top left-hand side, and it was like, I want this. And so, can you do this? Okay, I'll add another couple of systems in, we'll build a couple of interfaces, and project managers, it's quite a nice little industry, but the net effect of this is more and more systems, more and more interfaces, and all the problems we saw earlier. So the real change was a Conway law change, which was to group the systems into platforms and then organizationally arrange your budgets around an organization whose responsibility was to deliver those set of platform capabilities. So notice this wasn't a technical change. The transition from the top left to the top right, nothing changed technically. What changed is the way it was funded and managed, accountability, and people looking at what's the value of spending money in those areas. So then the technical step is once you've got all these systems grouped together, you suddenly discover you've got duplicated systems. And I can point to AT&T, MCI, Orange, Deutsche Telekom, all of this was common, endemic across the whole of the telecoms industry. So what people realized was that there's some rationalization possible, that when you put all these systems together, you could say, well, I could actually combine some of these things together. So now I get systems costs down. Then I can also start showing in red to introduce standardized interfaces which describe a service-orientated architecture, exposed service from one platform to another. And the goal is to move towards a architecture where you've got a smaller number of systems in each of the platforms, and all of the interfaces are based on service-based exposed APIs. And this has been quite beneficial for the TM Forum, I have to say, because we've run an API program which has been particularly successful, and we have about 70 APIs. So which is a lot reduced compared to thousands, and there's been pretty wide industry take up on it, particularly in the IT side of things, less so in the resource management area and the networking area. Again, that's another example of Conway's law. The network people do stuff differently from the IT people. That's the storyline there. So looking forward a little bit from where we are at the moment. So what I was showing you there is basically the state of the art for most of the current developments. But where most service providers are at this particular point in time is they're starting to look at the adoption of AI. And they're also starting to look at autonomous networks. And I've got a few slides to talk about things that we've been doing in the TM Forum and other organizations about what's coming next. Now, all of this is uncertain. It's as uncertain as software was back in the second era of using software to automate manual processes. And the risks are unknown. The costs are not known. So there's a lot of experimentation, proof of concept and stuff like that. But this is the best sort of assessment of where we're at. So one of the drivers behind this is a business driver. Currently, most of the processes are quite highly automated, and it'll vary between 95 to 99% of the processes are fully automated with the current processes. So then you say, well, okay, so the argument goes, AI can do all this stuff. But when you say, well, what difference does it make to this number? The story's a little bit different because all the simple stuff's being done. The 5% that hasn't been done is the complicated stuff. And the other thing is that for some processes, your business case has got to be on improving the last 1%. So these are extremely stretching return on investment targets, particularly when you don't trust the AI, you don't know how to manage it, you have no idea what the operational costs are, and you're now looking at relatively small gains. Now, there are some gains. Now, the gains are that you may have a more flexible, agile approach. And in fact, this is probably one of the most important things, is that a lot of the systems that we have that are highly automated are statically defined at design time and not very flexible. And what I see from, say, Chinese operators is a huge investment in experimentation on AI solutions. And I have an example of one of those a little bit later on. Now, humans are still in the loop for complex planning and assurance purposes. And so one of the questions is do we still need humans to do these things that somehow humans have always been doing? Can we automate some of the design and some of the planning stuff? Well, right now, that's definitely happening. We've seen examples from China Telecom planning the routes for a high-speed railway where all the surveying's been done by drones. That covers both physical geography, also vegetation, which affects the transmission characteristics. All that information is fed automatically into planning tools, and AI reasoning is used on top of the existing algorithmic tools to come up with the first pass of what is a good solution for planning a 400-kilometre mobile phone mast setup. And so the answer to this is yes, we are seeing some examples, but in those examples, we're still at the point where the humans are in the loop. So the AI is really an assistant rather than replacing all the decision making. And that's probably inevitable because planning takes some time, there's a lot of capital involved, and humans aren't going to hand over to a machine the decision to sign a purchase order for this, that, and the other without somebody actually supervising it. Now, there are some other examples around diagnostics. And this is one of the most important areas for possible use of AI. Now, typically in outside line plant, this isn't very interesting. This is like poles, holes, all this sort of stuff, but it's where a lot of money is spent. And if you look at a typical netco, 50% of the OPEX costs are probably around running the physical network, sending people around in trucks. So this might not seem to be very exciting, but it's where the money is to be actually saved. So, for example, these numbers on running truck rolls will be in the billions of pounds for most tier one operators. So if you're looking for return on investment and attacking some of these complex problems, these are the areas that you need to be looking at. And for example, in Australia, MBNco, which I've been doing quite a bit of work with, they have a pond network which has 64 customers on the end of the pond network. So if you get a fibre break, and you haven't thought about this, each of the customers phones up and says service has gone down. So he sends 64 trucks out, none of which has got any fibre splicing gear or any time domain reflectometers. So you now need to send out a 65th truck. Now, they did think about this, and it's not quite that bad, but you can see the point is that where the money is to be saved is better reasoning and better analysis in areas where you're spending a lot of money. Now, on the repair side, the interesting interplay here with the AI work is that if you can do predictive work, you can probably get on top of this quicker than you can do by just waiting for the alarms to come in from the customer. That drives up the customer experience. It also means that you may be able to remediate, not necessarily in the access network, but elsewhere. You may be able to remediate things. So the fixing of the fault isn't sequentially experienced by the customer, so that you fix the fault out of band with from the customer's experience. You remediate the fault from the customer point of view, and then you actually go and repair the fault. I have to tell you that in a meeting we had in China with a lot of bright Chinese graduates in AI, the concept that outside line plant could be of any interest whatsoever was a completely foreign concept. And the idea that AI had to pay its way was also a foreign concept, I have to say. But they were bright guys, and it was a good discussion. Now, there's also a change of integration model. So typically, we're moving from purely predetermined design time processes. So in the software automation, we know what the processes are. We know what organization we are or we want to be. So it could be a to be or a as is organizational thing. But we're basically a load of people design the processes, go and automate the processes. Now, what's happening is that with AI-based solutions, we're moving towards an intent-based approach where there's delegation and coordination between agents, and this is happening at runtime. Now, interestingly enough, BT Research did a lot of work on software agents around the year 2000. And indeed, if you look through the papers, there are quite a few published papers. It's just that the technology has caught up to the point where some of these concepts are actually practically realizable. And there is also this move to autonomous systems and networks. So I'm seeing networks, if you go and try and buy something from Cisco, Juniper, Mavenir, they're all on an intense self-healing based model. So the networks themselves are now intelligent. Now, why are they doing this? Because they want to add value to their product. So instead of being a dumb networking product, they're saying we can add all these extra functions in. So now, if you want to go and buy from Cisco, Juniper, they've all got these intent-based interfaces on them. So the idea that you can use the old methods of, low-level prescriptive interfaces onto networks is going. It's just like you can't buy that stuff anymore. So that's one of the other things. And the other thing is too that what the network providers are saying is that they can provide some level of self-managing, self-healing and self-remediation. So they can say, if I'm running a router like an SDN network, I can remediate the faults. But the bit they don't tell you, of course, is that there's still a fault. And if it's a fault in a fibre that you've bypassed, somebody still has to go out and fix the fibre. And the question is, where is the fault? And can I send one truck to the right place to fix it right first time? And that's the challenge that the industry has at this particular moment in time. So what's happening in 2026? So that's this year, okay? What I'm seeing is that the internet is pervasive in everything. Everything's based on internet-based connectivity. We're starting to see digital optical transmission in the access network and also in the core network. But what's interesting on the operations side is there is actually a convergence of the IT technology that's available to the networking department and also to the IT department, because that's all driven by the IT industry. And that's characterized by cloud computing, which is now being used in some cases in the networks. And also there's a telecom specific issue about sovereign data. And that applies to both the network data and also to the IT systems. So we're starting to see that, and we're also seeing common usage of AI and machine learning. So where we are at the moment with many suppliers like Vodafone, for example, is that they want to control access to AI by their employees. They want the employees to access, but they want to have some control and visibility of that. So they're building API gateways which allow individual members of staff to access whichever large language model or AI technology that they need, but subject to corporate rules. And one of them is you can't pass sovereign data there. Basically, that's the so this what's happened is that the technology basis for building the networks, large parts of the networks, and also the operations side is starting to converge on. Everybody's talking about cloud computing, virtualized machines, Kubernetes, all these sorts of technologies, and the AI machine learning stuff is complicated because the technology is changing on a quarterly basis. So the large language model that was the hot model at the beginning of last year is not the one that's the hot model at the end of this year. And what that also means is we're starting to see discussions about network operations and self-service for customers, starting to talk about AI interactions, about, well, we're going to use AI on the self-service. I've got an example of this for agents that work with customers to establish what the customer wants. And they need to be able to talk to operation centers, which are also being based on the use of agents in two forms, either as co-pilots or completely autonomous systems. And so the question that's arising now is the interaction needs to be based on some form of AI interaction mechanism. So there's a technology shift from design time deterministic processes. We're moving to autonomous systems and networks. The ITU has changed its TMN stuff to be described as smart operations, maintenance and management. And this is all based on AI, data infrastructure, service-based infrastructure, all of these words that we're all very familiar with, like OSS and BSS, all completely purged from the documents. It's based on intent interfaces, which I'm going to say a little bit more about in a minute. We're also starting to see the emergence of the use of open data and the use of semantic web standards. And I think a few of you in the audience are probably familiar with this, but this was also work that I know was done in BT around about the year 2000, funnily enough. And we're starting to see a real upswing in the industry towards the use of semantic web concepts. And the difference is that a lot of the design tools we've used are closed world models. The semantic web is designed right from the outset to be able to incorporate data from anywhere it happens to be. So from a repair point of view, you might need to have information from weather stations. You might need to have information about roadworks, because when you're sending the truck, you want to know, if I send it from this centre or this centre, this one's got a blocked road, it's all being dug up. You need to know whether there's street works taking place in the area that you're doing. So you need to integrate information from non-telecom sources and the only models that work are these semantic web models. They're based on a standard called resource description framework. Also, there's a move towards AI agents. Last year was the year of AI agents. The discussion in the industry was all about how an agent and a defined task. And one of the advantages about agents, particularly with defined tasks, is all of the problems of hallucination with large general purpose models. A lot of those start to go away because you can start to say, this agent in this context is not trying to solve world hunger, it's trying to solve this problem. So the allowed behavior, the scope of behavior, the guardrails are much easier to define if the agent is actually only dealing with a subset of the overall problem. So it's a bit like a delegation model organization. So the other thing is too that we're seeing with agents, and this was done in the software agents work in the year 2000, you need to be able to delegate responsibility from one agent to another, so you can carry out some sub capability. And you also need to get agents to autonomously talk to other agents to share information between them. And so we're moving from a model of like a supervision model of go and do this, go and do that to achieve this outcome. Basically, that's the changes to. Stability and reliability is unknown at this stage. That's why there's lots of proof of concepts taking place. Guardrails, it's not clear exactly how to write these down in a systematic fashion, which is something we need to do. And there's a whole set of issues around governance, regulation and compliance, because particularly in telecoms, the critical infrastructure and the Telecoms Security Acts require that you can demonstrate that your systems are safe, secure, and will run in the face of attack. And we're not at the point where you can do that completely confidently at the moment. Yet the pressure to move towards these solutions is extremely high because some of the early implementations do show some considerable benefits. So the TM Forum about 5 years ago put together an autonomous network framework, and it said, well, we've got all of these on the right-hand side. We've got business operations, service operations, resource operations. We want to define platforms, and we want to come up with a simple model that we can have one solution configured at runtime to perform as if it is business operations, service operations, or whatever. And the other complexity is that you need to be able to run control loops. So, and I'll say a little bit more about this later. But when you've got an AI agent, it's running a control loop. It's looking at stuff, it's analyzing it, it's making decisions, and it's executing decisions. So control loops actually come into this. Now, in most previous processes that we've done, it's been assumed that some process or another does this, and it's been sorted out as part of the design. That's supposed to be off. So the other thing that we came up with is an idea that each of these platforms would communicate using an intent-based approach. So the intent-based approach is a formal specification of intents in an expression language that's based on RDF that allows you to state what your objective is and the target to which you want that objective to be applied. And so what we did is we created this architecture and identified there were a few key parts that we needed to standardize. The first being the intent work. The other was what is an autonomous domain? What's the functionality that goes in an autonomous domain? Now, intent is the glue, and it's the same glue used throughout. So everything in this model is about intent being expressed by one platform to another. Platform say, I need you to achieve this objective. And it's one ontology and one interface. So the interfaces we've got, instead of it being an API for every possible combination of systems, it's an intent API. What makes it different is the data that is passed across the interface, which is held in a formal ontology or vocabulary. Now, what is an intent? It's basically, I want a network, system, or domain to achieve X with the properties Y. And you can see you can propagate intents from sort of like the service and the customer level. And right at the moment, we've got catalyst demonstrators showing how intent can be established from a customer and then translated into an intent which can be read by machine. And it defines all the expectations. It gives a goal rather than a recipe of what you've got to go and do. It's abstract enough for humans to understand, so it's not too detailed, but equally it's specified in a form that can be read and manipulated and processed by machines. It's also domain specific, so the intent expression is generic, but the targets to which it's applied, like services, SDN controllers, IP networks, things like that, that's where the specifics come in. And what we've done in the TM forum is we've defined both an API for these intents, and also we've defined formal ontologies for expressing those intents across those APIs. So a little bit about autonomy and versus automation. Just at time, need to go on a little bit. So when you've got a control loop, this sort of comes out of cognitive loops. You've got like an environment that you're monitoring with sensors, which gives you a view of where you are, what the world is right now. And then based on an intent and knowledge of how to analyze that intent, you make a decision about what action should I take now to bring the environment in alignment with the intent that's actually been expressed over here. Now, when we talk about automation, some of these steps are performed automatically, but the actual decision, the action at the end, is always performed by the human in an automation-based model. And then the autonomic is a kind of a hybrid between this and the autonomous view. Now, in an autonomous situation, you provide the intent and you let the system do everything itself. So it does the analysis, it does the awareness, it makes the decisions, and it takes the execution. So you're supervising it in terms of how well it is actually building or resolving these intents and how the network is actually operating. And there is a model. There are three models around. We happen to use the awareness, analysis, decision, and execution model. There's one that comes out in the military called observe, orientate, decide, act. And there's an IBM model called MapEK, which I forget what the abbreviations are. But these loops are essentially what these autonomous domains, autonomous systems have to implement. And the glue is basically being able to express intents from one system or autonomous domain to another. This is a sort of a maturity level model, which I think I'll skip over in the end. Now, the core concepts for autonomous networks are, one is an architecture, which is of autonomous domains or systems interacting using intent. There's an intent interface, which has the idea of an owner of the intent and an intent handler that then takes an intent from the intent owner and says whether or not it can actually meet that or not. So it could be establish a local connection to this particular point, and it might be indifferent as to whether that's using fixed wireless access, copper, or fiber. So that's an example of a sort of a high-level statement of intent. There's a capability management, because we found in the service area that sometimes these intent handlers or intent managers need to be able to publish what they actually understand. So they might not understand every single intent expression, and they may not understand every kind of target object, and they can publish that as a mechanism. These are all built into the APIs that we've got. The intent expression is essentially an ontology, and we've done a pretty comprehensive job on that. That then allows you to use these intents to drive the cognitive loop, and also that which is within a domain, and also the closed loop interaction between domains. Basically, just keeping an eye on the time. Now, there's a use case that's just been put together by China Mobile, which is really on the customer experience side. Now, the challenge is that call contact center demand is rising, and there's a diagram here that shows the prediction of call center growth in various territories, and actually quite large in China. And the problem is they can't find people to staff call centers. Amazing. 1 billion people can't find enough people to run call centers. Interesting. But the reason is that it's not a very popular job, and there's a lot of competition at those wage rates. It's high churn. Finding, training, and maintaining human agents is very difficult because you have to do all this training. Because if you don't do the training, they don't operate consistently, and that drives your customer experience down. So what they're now thinking about is what can we actually do to improve customer contact using AI? And they had a couple of things going on here. One is this. I'm not expecting you to read the whole slide, but just the general story. One of them is about a customer working with effectively a chatbot, and the other one is where the customer works with a human agent, but there's some pre-screening done by Copilot, and there's also a coach that supports the human agent to actually carry out the processes. So it's like, you know, recommendation about what to do. Now, this sort of right-hand side shows the kind of screen interactions that they're proposing. This is there's a trial being done, and we've got a Catalyst project coming up at our event in the middle of the year on this. But these show some interesting things because it's not entirely fully AI. You know, the one at the top will handle some of the cases. And I think this is fairly well understood. You'll see quite a few chatbots are in this space. But what's more interesting is this sort of like agent-oriented solution where you pre-screen, then you bring in the human agent, and then you provide AI support so that you've got the consistency that you need in the customer contact center, because that directly affects net promoter scores. So that's the kind of thing that we're starting to see. So here's some of the challenges. I think this is the last slide. The challenges for telecom AI operations. There's a bit about use case and credible business cases. So we've had an exercise on use cases for AI, and anybody can produce them. You can produce hundreds of them, but the real test is, do they actually work, and what do they cost to run? And is there an ROI on it? Because, as I said in the first slide, telcos are risk averse, and so that hasn't changed in 40 years. So the areas where things are experiencing some reasonable use cases around customer experience, like the example I just gave, which is slightly bizarre because you would have thought that, you know, in those countries you could actually find all people, but actually the thinking in China is pretty well advanced because there is a government initiative to get AI used pervasively across all industries, and particularly those that are state-owned. But the other one we're seeing is around network assurance and planning, and this is driven by OPEX and CAPEX, and we're supporting these with some demonstrators, which we call proof concepts. And these seem to be the two areas that keep coming up as like, we could actually produce a reasonable business case here, because we could talk about net promoter scores and what the effect on sales is there. And we can talk about OPEX and CAPEX costs on networks. So these are areas where you can credibly put some numbers together, which aren't completely fictitious, that you could put in front of a finance director and say, this looks like a reasonable case. That only leaves you with the uncertainty of the costs and all those other things. But the other thing that we've seen is the need to move towards data. So the dirty secret about AI is if you haven't got decent data, it'll make some really bad decisions. Now, for those of you who've been in a large telco, you know data quality has been an issue for my entire career, okay? And moving to distributed systems has only made this worse. but it actually turns out to be a first-class concern. And it's also important because there are data regulations around various parts of the globe, particularly around personally identifiable information and critical infrastructure. So it's getting to the point where this isn't like a little dirty secret within each individual operator. It's like you have to report to various legal entities about how you're doing. So it's no longer a little private secret. And what we're looking at is data as a product and knowledge as an asset. So instead of regarding data as a technical thing, think about it as an asset that you're exposing as a product or as a service. And you've got stakeholders, responsibilities, and quality metrics that you need to achieve. And what that will do is give you frictionless data, knowledge, and wisdom. Wisdom is the ability to reason on the data. So data is used as a simpler word, but actually data, there's a semantic web concept of data information, which is something about the structure of the data. There's something about knowledge, which is semantically understanding what it is, and wisdom is about how to reason about that knowledge and make decisions, which is obviously what you want AI to do. And the other issues, there are definitely some scale challenges in the network space. So in last year at the Ericsson event in London, it was an OSS BSS conference for their customers, Mark Saunders from Telstra got up and said, 2026 is the year of ontologies and data. He said, we have to fix this. And Richard Kendall from MBNco got up and said more or less the same thing. But what was interesting was some of the numbers. If you're going to use some of these concepts on data in sort of like networks, you can run into 1 billion entities just like that. And so that raises a lot of issues because a lot of the AI is based on building a knowledge graph. And it's just the case that a lot of the technology around won't handle, not all of it, but there's a lot of it won't handle at that scale. So you need to subdivide it, which raises quite a number of interesting practical implementations. And that's a major discussion point at the moment in the TM Forum. Now, security and privacy is quite important because there's regional regulation on privacy, and it's getting worse because critical infrastructure, there's certain things that you will not want to be able to expose. You need to have evidence and auditing procedures, which are often to be done by AI agents themselves, to check that you're actually complying with the regulations. And actually, I think there's going to be quite a big growth in this. And it's a bit odd, the AI checking the AI, but that's where we're at. The other thing that's become quite clear is, what is the AI ops? And we have a substantial amount of work on this, which is, what does it actually take to manage AI? What is it that you're actually managing? Where are the threats and those things? And so what we found is there's multiple life cycles that you need to manage in AI. There's the training models, there's the software that you're bringing in, the actual large language models. You need to understand what you're doing there. You've got operational data coming in. You need to know, where's the origin of that? Do you trust it? You've got digital twins, which is to be able to pull data into a knowledge graph over which you can perform reasoning. And there's also supply chains, because you've got stuff coming in from suppliers in all sorts of forms. So it's not just internal to yourself. You've got to have some kind of provenance structure or governance structure that works across multiple organizations. And then there's integration with industry APIs. So there's proposals in the Linux Foundation of something called Model Context Protocol and A2A, promoted by Anthropic and Google. And these have definite gaps with respect to what's required for telecoms. So those, I think, are the main challenges that we're seeing. These are the hot button topics that we need to go and deal with. So in summary, what we've seen over a 40-year period is a move from manual administration, where there's a focus on customer experience and telecom operational efficiency. And we've seen 3 decades of IT-enabled automation. And now what we're seeing is the early steps towards evolving towards an AI-enabled autonomous systems and networks. Now, paradoxically, it's actually moved by the fact that the network suppliers no longer supply traditional networks. They're supplying things that already got intelligence in them. So you now, even though telecoms is risk averse, there's no choice. We have to go into this direction. There's also quite a bit of stuff happening on open source and reference implementation standards in that particular area. And I have to say, after 40 years, Conway's law still applies. And the benefits require organizational change and mindset changes. So in the end, it all comes back to how are you organized? Are you organized for the past, or are you organized for the future? And on that, I think I've just about made it in time. Thank you.
Thank you very much, Dave. Fascinating journey through time.
Yes.
Right, we'll move on to some questions. Can I just make a plea, if you're online and you have a question, please submit it on the Q&A panel, and George in the room here will pick it up, and we'll ask Dave the question. And what we'll try and do is to move between questions from the atrium here, University of Suffolk, and online. So who would like to ask first question? Gentleman at the back.
This term AI is used. Yet I noticed you had one slide AI/ML.
Yeah.
Is there a problem that actually we're being too vague about what we actually mean by the?
Yeah.
Because in some cases it's ML, as in it's a very targeted set of data around a particular problem, and in the other case it's
marketing. Everybody has to talk about AI at the moment, but actually, when you look at telecoms applications, a lot of them, machine learning based approaches with narrower data sets, are perfectly workable. They also require smaller data sets, the training is cheaper, and they're more targeted, and they're less likely to hallucinate and produce incorrect results. But what is interesting is a lot of this technology that's been emerging recently is sort of driving the cost point to a different place. Instead of it being developed, on a case-by-case basis, there's some general purpose technology that can be used. And, I think if you look back at some of the work that was done in BT Labs by Michael Waldridge at Oxford University on software agents, essentially most of the ideas were around machine learning and cooperating agents. And what's changed is the widespread availability and pervasiveness of IT technology to do some of this. But I don't think you need large language models for everything. In fact, I'm quite certain you don't. There is another point worth mentioning, is that there's quite a topic about tokenization costs. So when you actually go into a large language model, you have to provide some context, which is usually a set of data which you put in. And a lot of the charging is based on the amount of data you put in. So the less you have to put in, the better. And it also varies a lot from one supplier to another, what those token costs are, the latency for responses, accuracy for responses. That's why companies like Vodafone are building sort of tools to allow their staff to access these things, but they want the evidence about what the token costs are, the effectiveness of that. That's why they've invested in that. So, I'm a fan of machine learning, to be absolutely frank. Thank you.
Excellent. George?
I have a question here about intent-based interfaces and autonomy of the agents. And when you delegate, the agents must have some internal view of what a utility function might be, which they would be seeking to optimize. And can you give some examples of these kinds of utility functions that you're working with?
So actually, as part of the intent language, we've introduced a set of utility measures, which describes essentially what you're describing, which is what the utility. So typically, you might have several intents going into a system, and you need to be able to describe the relative value of achieving one intent versus another, because ultimately, because you've got an abstracted view, it has to make a decision about optimizing against multiple intents. So you have to have a utility measure about the relative value of these intents. So one might be like highly important that you meet this, and the others might be good to have, nice to have. So that you do, we already got that in the modeling language. I think this is publicly available. If you go on the website, I think there's a version of this in on our website, tmforum.org. I think it's IG 1253. I think it's a publicly available version of something on this. Yeah.
Thanks, Dave. Another question here in the atrium. Anybody else like to ask a question? Russell, sorry.
Back in the 60s, to what extent were the organisations and manual processes of the operators in the different countries the same?
Really similar. At the time that BT was introducing digital systems, that was pervasively happening across Europe. The main difference between the UK and other countries was that we were stuck on rotary equipment, and a lot had moved over to crossbar or reed-based solutions. If you look at it in terms of the population of systems, we were more at the rotary Strauger end, and countries like the US were already moved away from that to other forms of analog switching. But the real change was when we started to see the move towards digital software-driven exchanges, which happened more or less concurrently across the whole of Europe and North America. With Nortel, AT&T had systems in this area. We had our own. There's the ITT systems.
System 12.
System 12, that's it, yeah. There was quite a few, everything was happening about the same time. What was enabling this was a realization that maintenance costs for analog exchanges were poor and the world was going digital, and both the exchanges and the management of the exchanges need to take advantage of effectively the IT and the semiconductor industry.
But didn't you have things like Belcore standards, Dave? You could talk about that.
Yeah, so interestingly enough, Belcore, which had a rather checkered industry originally with AT&T, then spun off as a sort of a neutral body. Then it was bought over by Ericsson. They used to provide standards, particularly around the integration, and they had got a lot of internally developed systems. So the validation and testing they were doing was whether a particular supplier's switch or an application could be managed by their existing application. It was quite a nice revenue earner until people realized that you could buy best of breed products from elsewhere other than Belcore. And that, I think, was really where the demise of Belcore started, is they didn't have this lock on large monolithic systems. It was breaking down into distributed systems and best of breed. So I think that's kind of where the main changes were.
Thank you, Dave. George, is the question online at all?
Yes, I have a question here from Steve Ashdown. And Steve wants to go back into the older parts of the timeline where the BT and GPO had amazing engineers at the cutting edge of technology and were responsible for training and releasing many of them, technicians and engineers, into the greater industry. As we've moved along the timeline into contracted out services, how, I'm not quite sure who Steve thinks is we, how we avoid brain drain and the reluctance to develop technicians and engineers for the country, I think it's UK obviously, and the reliance on external territories. Is this not an infrastructure risk?
Yes. So one of the other jobs I'm doing, and I'm working with the UK government on a group called the UK Telecoms Innovation Network, and the government is definitely interested in investing in telecoms and rebuilding a telecoms capability within the UK. I think it's unreasonable to expect, a national champion like BT to pick up the whole burden. And there's certainly quite a lot of discussion about following out the need to build up industry capability in this area. And it's to do with the fact that telecoms is the most critical infrastructure. I mean, the water doesn't work without it. The railways don't work without it. Everything else doesn't work if you haven't got telecoms working. In fact, the only close competitor is the electricity industry. So there's a definite recognition in government, at least from what I'm seeing, from my involvement, that money needs to be invested, and it needs to start to be invested in the universities and technical colleges to start to build up the capability. But equally, those people need to have somewhere to go. There has to be some industries. Now, there's a tendency to want to look back at the past. It could well be the future is not like building another Ericsson, in the UK, but building something that's got a much narrower set of objectives, which has got export potential. And there's a lot of potential around AI, by the way, where the UK does have some natural advantages. So telecoms and AI could be a very good area to start to look at investment. For example, on the data capture side, building tools that allow you to integrate data from multiple sources, and to do that on a semi-automatic, data-driven approach could be quite a good business investment. In fact, I think, Martin, wasn't that Ontology's business, I think? And you got bought over by IBM. So we need to be investing in people and industries of the future rather than saying we're going to recreate something in the past. That's too lazy. You've got to think innovatively about where you need to get to. And it's quite clear the telecoms industry isn't as strong as it should be in the UK, particularly as it is a critical piece of infrastructure.
Thanks, Dave. I believe there's a question at the back there.
I was going to say, in terms of if you've got OpenAI that create something that's sort of intent based as opposed to pre-configured. Years ago, when we put we had System X first going in, you could create different services in different ways. And originally, one exchange might have been pre-configured one way, another exchange might be configured a different way to provide the same service. So if we have the intelligence in the network that's going to possibly create things in different ways to achieve the same sort of objective, how do you manage it all? What's it all this stuff is out there?
Okay, so
Does that make any sense?
yeah, I'll sort of summarize where I think the question's coming from. So now that equipment vendors are delivering self-healing networks which have got intent interfaces, they happen to be based on an IETF specification, which is a bit limited to networks, whereas ours is much broader. What work we've done is broader, and there is a relationship between the two. But the critical point, I think, here is that once you delegate to something to go and do something, you need to have an observability model. You need to know what is it doing. So I'll use a human analogy. So a lot of our early automation has been like running a shop, and you've got a set of employees. You say, go and fill the shelves over here, go and do that. Where we're moving towards is these agents are taking on roles like a managerial role in a delegation model. But you've got to have techniques for observing, are they actually doing? How well are they doing against the targets? And rating them. So it's a little bit like management in an organization. You delegate somebody a task, you've got to have some mechanism for determining whether they're doing that. That is definitely emerging, and observability models of semi-autonomous systems, we're seeing that both in compute environment and also in the networks environment. So observability is the other big question, but observability depends on having good quality data, which takes you back to data architectures, open data worlds, and things like that. So that's where the action is. Now, that's exactly what I've seen reported by Telstra and NBN Co, is they have got delegated networks, but they are putting a lot of effort into observability, as indeed is Swisscom. The Swisscom had quite a good presentation with us, which was very much about observability. So it's
observability model with the AI level learn. In other words, say you configure different things in 3 different ways. You can observe those 3 ways. So this one turned out to be the best one, for example. Yeah. Does that learning then all?
I didn't discuss this, but there's multiple loops at multiple timescales. Yeah. So in some of the early work that we did, we had what we call short and long timescales. So there's something that's acting tactically within its remit, but it's also reporting through observability. And some say this particular agent is having some problems because it basically doesn't have enough resource budget to do what's needed. So I'm looking at this on a slightly longer term scale, and we can solve these problems that this agent's having by giving it more compute, more storage, or whatever it is that it needs. So you do need multiple levels of this, and some of it is driven by the customer. I've got an intent, I want this. And some of it is an operational view, is have we allocated enough resources to this agent for them to effectively be able to perform what's required for the end customer? So these loops are all interacting. The stability mechanisms for these are unknown.
So some of that sounds like it's like reactive and proactive?
Yeah, exactly. So you might say, well, this particular agent, we're seeing some issues here that it doesn't always respond as quickly as it should do. Why would that be? So somebody does like a what used to be called black spot analysis and say, well, actually, I've determined what the problem is, that by looking at what it was doing, it was running out of storage at a certain point in time. So that's sort of an example of where you would say, well, okay, if we improve the storage, then it can go away. The other thing I've seen from work we did with AT&T is sometimes some workloads don't work very well on certain versions of processors. So you could say, oh, well, we won't schedule that program on those kinds of processes. We'll, set a rule which says these always have to run on these other processes. So there is a sort of a supervision model. So if you take the human model, where you've delegated to somebody, you're observing what they're doing and deciding what they need in order to do their job better and how well are they doing it. So what we're seeing is an evolution of a human model with AI agents. And if you looked at children, for example, and how they build up their skills, I think we're going to see the same thing with AI, is that, it's like this is a 1-year-old, this is a 2-year-old, this is a 3-year-old. And over a period of time, you get to a point you say, this particular implementation of an AI agent doing this, I'm now confident is an adult, basically. So I think the analogies are quite interesting in this area.
Thanks, Dave. George, I think we take one more question online and one more from the audience.
One more online then, and the question is from Tim Albis, and he's asking about the privacy and I think sovereign data and so on, and he's asking, how are legal frameworks addressing AI privacy and security in that context?
Well, I think what we're seeing is regional requirements emerging in this area. What we're doing in the TM forum is that when you look at privacy, you've got to have some rules. So you've got to have somebody who describes the rules in a machine readable form. You've got to be clear where those rules are enforced, and you've got to have audit statistics to demonstrate that the rules that you set are actually being executed correctly. That's the general model that we need. There's actually a current discussion because it's quite complex, because when you look at data, there are things like data custodians, data owners, data controllers. There's a whole set of roles that need to be related to data in order for you to effectively manage and govern that data. So, for example, a data custodian might be the person who does the day-to-day operations. The data owner might be a longer, a more strategic orientated person, and the data controller might be just a legal role, which is the point of contact between whoever the regulator is and the organization, that has to provide them with reports and everything and have evidence that what's happening in the organization works or not. So this is actually quite early days, and we are seeing companies like MuleSoft, which is part of SAP, I think it is now, they're starting to look at API gateways and building effectively privacy controls onto API gateways, which is an early step, I would say. I'm not sure it's the whole story. It's like a technological step, but you have to answer these organizational issues. Back to Conway's law again.
Thank you. Any more questions? Chris, a final question from Chris in the atrium.
Thanks, Dave. I was just wondering from this whether telecoms and network companies are being forced into AI-based solutions in order to support a future world which is going to be dominated by AI, from which people of like Mr. Musk, Mr. Zuckerberg, and Mr. Bezos are making vastly more money out of the telecoms networks and the telecom network operators.
Well,
is there not a harder bargain for the telecom network operators?
Yeah, well, I mean, there's a general issue about margins in the telecoms industry, and there's several reports around. If you look at Telecom TV, we produced one recently, like where are the opportunities for telcos in the future? Because you can't cut indefinitely. There comes a point at which you've got to have a growth proposition. And that's not clear entirely at the moment, but I'll give you an example of some of the things I've seen in this area. So there's a lot of work about network APIs, where you've opened some aspects of the network, things like verification, people being in a particular location or being a particular person. So that's one level, which is kind of today's world of like transactional APIs and providing information. Now, the service providers have got some strategic advantage in this area because generally they've got, you know, mobile phone devices and they can associate a device with a person and things like that. So they've got some competitive advantage. Not very exciting, to be honest. Not really. I think the forecasts on the revenue are modest. But what I'm seeing in particularly China is an idea that the interaction between the customer and the service provider is entirely different. It's more like there's an agent that you work with that does stuff for you. So it acts as an intermediary. So it could, the telecoms operator could set up an agent. And somebody says, book me some flights, or can you get this document, or things like that. So it's more like a personal assistant type model. That's actually quite interesting because it completely changes the transactional model between the customer and the service provider to be something that's closer to something that the consumer actually values. So, and that would give the telecoms operators an opportunity to compete with some of these others. And then you have to look at some of the differentiators. One of them is around response times. So an underexploited area is around edge. So most of these hyperscalers can either provide equipment on customers' premises or they can provide it centrally. But in that middle ground, there's a whole class of applications which they can't do without the operators. And there's an opportunity for a hard bargain in this area, I would say. But I would say this is very uncertain at the moment, but there's a lot of discussion in the industry about where are the future revenue opportunities for telecoms operators. But everybody goes back to like adding something onto connectivity. It's something about the business role that service providers perform, like a trusted entity. It's those kinds of characteristics, which is probably where the future is going to come from. At least that's what I see in the discussions.
Well, thank you very much. I think we'll draw the event to a close now. Thank you very much, Dave, for an excellent talk and for taking so many of the questions.
That's my pleasure.
Please join me in thanking him. Before we finish completely, I just want to do a little plug for some of our next events. So this is where I encourage you to come along to future events. I've got some listed up here. The next event we've got is the 24th of February. We're going to hear from Clayton Nash, who's a strategy director of City Fibre, and that's going to talk about City Fibre 5 years on. I think we had Clayton talk to us about 5 years ago. So we'll see how City Fibre have done with their promises and how they're getting on. The second, the next lecture after that is going to be the 18th of March. That is confirmed now. I put to be confirmed, but we've just confirmed it. Kevin Holly, who's a distinguished engineer at BT, he's going to talk about the history of messaging and SMS. And then in April, we've got an online lecture only. And that's from Professor Emeritus Peter Grant, University of Edinburgh. And Peter's going to talk to us about the cavity magnetron. So that's just the next 3 months or so. We have a program which spans the whole year. There'll be other events that we announce. All our events are available for registration on our IET EngX website. And I've just done a kind of little screen snip on the top right there. The red arrow is just indicating where you can register for the events. And if you'd like to visit our website, I've given the URL there. There's also the QR code. And as I said at the start of the talk, the CPD certificate for this event, I'll post that on the website probably tomorrow. And with Dave's permission, we will publish the slides and the video. But we want to review those with Dave to check he's happy with that. Get his permission, and then I'll upload those. So slides and video.
That shouldn't be a problem.
Good. Thank you. So once again, Dave, thank you very much.